Have you ever wondered why a cup, despite its weight, doesn't fall when placed on a table? It seems like the table is adding some mysterious force that pushes the cup upward, preventing it from dropping. But is that truly what's happening? In energy filament theory, the table doesn't add any extra force to the cup. Instead, it uses its entire atomic structure to rearrange the texture of the underlying energy C, locking the cup into a position that represents the lowest energy state for the entire system. Imagine the tabletop as a surface made up of layers of springs, each one connected to the others. When you place the cup on the table, the spring directly beneath it gets compressed more than the surrounding ones, creating a pressure that the other springs help to distribute. This pressure spreads out in waves, much like a relay race where each person passes the baton to the next. In this case, the baton is the pressure that is transferred to the legs of the table, and eventually, the energy is spread through the ground and into the larger energy C beneath. What you see with your eyes is a cup sitting on the table. But what's really happening is an intricate system of pressure redistribution. This concept of redistribution of forces explains why the table might seem to sink slightly where the cup is placed. It also helps us understand why thinner materials, like glass, break more easily than thicker materials, like wood. When a cup is placed on a thick wooden table, the wood distributes the pressure more evenly because it's like a team of strong individuals working together to share the load. However, a thin piece of glass works more like a few fragile individuals who bear the entire burden. If the stress becomes too much for the glass to handle, even a small amount of pressure can cause it to crack, revealing its inability to bear the load. Now, imagine you are standing on the ground. The weight you feel isn't some invisible force pressing down on you from above. It's the interaction between your body, the floor beneath you, and the earth below. These forces are constantly pushing against each other to prevent you from sinking into the ground. The support force is not some magical upward force but is, in fact, the result of all these components adjusting and redistributing energy to keep everything in balance. This is the key to understanding support forces. It's not an abstract concept but rather the outcome of a complex system of energy redistribution. When a table holds a cup, the energy C, through its texture and forces, makes sure that the cup stays in a stable, balanced position. Similarly, when you stand, the earth and the ground help you stay where you are, not because of some invisible force, but because of a system that continually adjusts to keep you in equilibrium. The table and the earth are, in essence, always working to ensure that everything remains stable. This is why certain materials, like thick wood, handle weight better than others, like glass. The redistribution of forces ensures that some materials can handle more stress before they break, while others reach their limits much quicker. The concept of support forces is crucial to understanding how the world around us works on a deeper level. It's not about some mysterious force being exerted on objects but about the balance and redistribution of energy through structures. In this sense, even when something appears perfectly still like a cup on a table, or a person standing on the ground, it's actually the result of a complex web of interactions within the energy C that's constantly adjusting and balancing. The idea that the universe works in this way is fundamental to understanding how all of nature operates. In the next episode, we'll take a closer look at why lighter materials like glass are more prone to breaking under pressure compared to stronger materials like wood. Understanding these subtle differences in energy distribution will reveal how the world around us behaves in ways we might never have expected. Tap follow, share it on New Physics, Clear Universe.